Okay, so for 14.1 we have double integrals over rectangles. And our first problem in this homework section is the double integral from -2 to 0, -3 to 3 of x plus 8y plus 19 dx over dy. And so what we're going to do is we're going to take the x, integrate with respect to x, and then integrate that with respect to y. And it might be better if we take this and just write it in different colors. We're going to do this in blue, and then this in red. And kind of keep our integrals the same. It's kind of important to note that the rectangle here, R, is actually -3 over 3, your x values, and then this would be your y values of 0 to -2. Kind of look at that straight up and down. You have your xy plane, and it goes from 3 to -3, and from 0 to -2. The rectangle is something like this, and then we're taking into account what's happening above this rectangle, which is this function. That would be basically your z is equal to x plus 8y plus 19. And then we're going to find the volume, or the under this, in between this surface, which is your plane, function, and then the rectangle. And that's going to be the final answer, is the volume in between the two. So starting off with the blue, we have the integral of -3 to 3 of x plus 8y plus 19 dx. We're just going to treat y as a constant here. We're going to get that x squared over 2 plus 8xy plus 19x. Just basic integration rules apply. Taken from -3 to 3. And then we just plug in. We get 9 over 2 plus 24y, and I'm plugging in my 3 here, plus 57 minus, and since this is squared, this -3, it's actually going to be 9 over 2 again, minus 24y minus 57. It's important to note that this negative distributes to all of them, making all their signs opposite, and this are actually added to this and this, so it's almost doubling it, making it 48y plus 114, and then this and this are actually cancel each other out. And now we're kind of ready to move forward into our red. So we take the integral from -2 to 0 of 48y plus 114 dy. From here we just get that 48y squared over 2 plus 114y taken from 0 to -2. And this becomes 24. I'm going to work this right over here. 24y squared plus 114y taken from -2 to 0. When we plug in the 0, obviously each term has a y in it, so when we plug in that 0, it cancels everything out, and we're basically going to have the negative 24 times a -2 squared plus 114 times a -2. It's important to note that this negative out here is also distributed through because of this 0 minus this. It's this minus that. So the 0 still stays out here, and we still have to distribute through that negative. And when we do our multiplication, we're going to get that 96, because this is, it turns positive. So basically it's 24 times 4, which equals 96, plus 228, and that's negative because of this -2. keep in mind our sign out here. We get negative 132. Opposite that, it'll show our final answer is 132. So to finally take this is the answer to the entire double integration. So if you think about it like this, you have a function above a plane of a rectangle, almost like this. Kind of look at it in 3D. Let's say that there's some curves in it, something like this, and then also you have kind of happening behind it. Some of it you can't see, some of it you can. So something kind of like that, and you're summing up this whole area right in here, which is this whole volume basically of the entire thing. So this is your rectangle base, this is your z function, and now you're able to actually sum up this entire thing. And so you can imagine the implications that you could pretty easily find out the volume of a multitude of different things just by understanding the rectangle and then the function that it would make above that rectangle. Thank you.